Sí, funciona.
Funciona. Vamos a comenzar. Bueno. Alice Grimm, no sé si la conocen o quieren que se presente.
A piada foi boa. Ok. Well, it's good to apply things we have been studying and something that can have real application. So we'll see now what is the skill of subseasonal prediction of the South America summer monsoon in several different lead times. Oh. So here's the outline. So I will first define monsoon indices because we will use them to assess this skew. Then I will talk very quickly. It's actually something I have already presented before, but also very quickly, the impacts of mud in Julian, because we'll see as the model, how the models, they reproduce this impact, and if this impact simulation is coherent with the phase of the MGO. Then, we will see the skill of two of the S2S models. S2S means subseasonal to seasonal prediction projects. You know about this probably. And there are 11 models that are being evaluated. And I chose two of them, and you'll see the reason. Actually, I can tell you right now, ECMWF is the model with best skill. So that's why it's there. And CFS is the NCEP model. So it's a very well-known model. And the greatest advantage is that it is publicly available. Anyone, any regional center can use the output in real time of the predictions of these models. Whereas here, ECMWF actually doesn't make available to the public their real-time predictions. So you have to pay for it. And then we'll see what is the influence of the MGO on these active and break phases of the South American monsoon. Why? Well, then we can see how important it is that the model reproduces the MGO and its impacts. What's the importance of this for the prediction of the South American monsoon? So we'll first see the impact of MGO on the South American monsoon, and then we'll see how the models represent the MGO. If this impact is great, is very significant, it's important that the models we will use reproduce very well the MGO and its impacts. Okay, and then we'll show the assessment of these subseasonal predictions. You already know this figure, and you already know the importance of the reversal of the zonal wind at lower levels here over Central South America related to the monsoon. So when we have this reversal, we have moisture flux into all this area here, and factors affecting this zonal wind component, this westerly zonal wind component here during the monsoon, these factors affect also the intensity of the monsoon. So we chose a monsoon precipitation index here in this region, as I already mentioned before, as a compromise between intensity of the monsoon, so the core monsoon region in terms of intensity is more or less here, but also it's important to consider the variability of the monsoon. Where is the region with highest variability of the monsoon? So, and this is a little bit more to the east with regard to the region with the highest precipitation. So we chose this region here as a compromise between these two criteria. Okay, and it seems that the choice really represents the variability of the monsoon, because when you make composites of OLR representing precipitation, convection, when you make the OLR composite of OLR anomalies for indices representing active days, you get this composite here. So this dipole, very well known already. For break monsoon, opposite sign, so subsidence dryness here and more enhanced convection here. So these composites associated with active and break monsoon days defined according to this index, which I will describe right now. You see that these composites have the same patterns as the first EOF, the first mode of variability in intraseasonal time scale. So the index represents very well this variability. Associated with precipitation here in this region, we have these patterns of zonal wind. So more precipitation here is associated with zonal westerly winds here and easterly here. So it's connected with cyclonic circulation here in this region. When a cyclonic circulation prevails here in this region, we have stronger westerlies here. We have more precipitation in this core monsoon region. So we chose this region to define a monsoon wind index, which is dynamically consistent, dynamically associated with this monsoon precipitation index. Well, the definition of this monsoon precipitation index is the average standardized anomaly of precipitation here over this region. When this index is equal or greater than +1, you have an active monsoon day. When it is equal or less than -1, you have a break monsoon day. That's the definition. So let's have a look at these indices. Here you have it for the season 2001, 2002, and here for the season 2007, 2008. So from December through end of February. Every day, these are daily data, every day. So you have here the observed monsoon precipitation index, which is this standardized anomaly average over that region there. And you can see here the thresholds for active days, so above 1, and break monsoon days. And here for this period, 2007, 2008. And what's here? Here you have this year is observed, are data from station. Rainfall gauge instruments, so this is observed. Here you have, in the same color, this monsoon precipitation index from the ICMWF reanalysis, which is the initial condition for ICMWF. And, well, when you compare this purple curve here with this here, you see that, well, there is correspondence. Here, here. There is some correspondence, but the reanalysis precipitation index is not equal to what you observe. And you can see that these very extreme events here, they are not that extreme here. Here you have 4 standard deviations. And here you have 2. So the model is already using as initial condition what the models consider as observation. He's starting from there forward. It's already not correct. And this is not just for ICMWF. All the models start with some kind of reanalysis, which does not represent very faithfully the observed precipitation. This, I think, is an issue that is not very much discussed, but I think this also has influence on the predictions. Okay, so here is the observed index, and here is the index here in purple as the model sees the index as the observed one, is its initial condition. Here you can see the same thing. Compare this purple curve here with this purple curve here. Of course, you have correspondence, but it's not a complete correspondence. Here, for instance, you have 3 peaks. Here you have just 1. And these are daily data. Okay, now you can also see in this figure the correspondence between the precipitation index, MPI is monsoon precipitation index, and monsoon wind index. The correspondence is not perfect, but you can see that variability is, well, more or less the same. So one index follows the other reasonably. Another aspect of these figures is that here we represented already phases of the MGO that happened during this period. And here, during this period. And, well, I can tell you that the highest impact of MGO in this monsoon core region happens in phases 8 and 1. And also in phases 2 and 7. So these phases 7, 8, 1, 2 could be considered the wet phases for this region, whereas phases 3, 4, 5, 6 could be considered the dry phases for this region, for the MGO. And well, here you can already see that there is, yes, an influence of the MGO on the variability of this index. You have these wet phases here associated with very active days of the monsoon, and these dry MGO phases associated with break monsoon days. The same here. But, of course, not all the active monsoon phases are associated with MGO. Not at all. And also not all break phases are associated with MGO, but there is a relationship and a significant one. Well, now here you can see the same, but for the reanalysis of CFS. So this curve is the same as before because it's the observed for the same year. This is also the same as before. What is different here are the two curves here because these are based now on the CFS reanalysis, which is the initial condition for the CFS model. And as before, look here, this very intense episode of active monsoon. Here it's 1.5 standard deviation, here is 4. Also here, 1.5, and here is 3.5 standard deviation. So there are really differences. Actually, the reanalyses are much more unlike each other than with the observed precipitation. They have more similarities between them than with the observed rainfall. So now let's a brief revision on the impacts, just to see what we have to expect from the model. So I mentioned that in phases 8, this is the upper level divergence field for the 8 phases, and you can see that in phase 8 and phase 1, you have strong and extensive anomalies of upper level divergence over South America associated with enhanced convection there. And you have here over central subtropical South Pacific also upper level divergence, here in 8, here in 1, and it starts here in 7. And this is responsible for the for this teleconnection. I showed it you before. I have a figure later on with South America. This anomalous convection in central East South Pacific. Okay, so here you can see the OLR anomalies, enhanced convection here, and winds at lower levels. You can see here these tropics teleconnections via Kelvin waves and also Rossby waves here over the equatorial region. You can see this strong convergence of these lower level winds, and therefore one can also suppose that there is strong convergence of moisture here that produces this strong convection in this region which match topography, as I show it, the the day before yesterday. This year I have already shown, so we can have more than 12 no, not 12, more than 35% above climatological rainfall just of anomalies due to MGO, because these are filtered anomalies. Okay, then you can see here that phases 8 and 1 correspond to above normal rainfall. Here in phase 2, you also have something. Phase 7 doesn't show much anomalies here in this region, although it's positive, but not significant. And these are the dry phases. You have something in phase 3, but very weak, and strong anomalies in phases 4 and 5. And in phase 6 is already shifted to northeast Brazil. The same for anomalies in the frequency of extreme events. They are very much reduced in phases 4 and 5 and enhanced here in the northern part of Central East Brazil in phase 8 and here all over this region in phase 1. I show it you that actually all these anomalies here over this extensive region, they don't have the same dynamical mechanisms. This southern part is due to extratropical teleconnection. This northern part is due to tropics teleconnection, and also northward propagation of these systems here in the axis. So here, just to look at these teleconnections from Central South Pacific that start here in phase 7, but are not completed. Here you can even see opposite sign of this important anomaly, cyclonic anomaly. So it starts here, and it's almost completed in phase 8, already producing some effects here, and then it's fully completed in phase 1. So this is a very important teleconnection. We'll see how the models reproduce this teleconnection. When the model does not produce, you don't have a good prediction. So, well, this you have already seen. Are these experiments showing if you put all these anomalies of upper level divergence, which seem to be relevant in the southern hemisphere, okay, you can get all this wave, apparently continuous wave train in here. But then when you do these simulations for isolated anomalies, you see that what is important for this connection to South America is really here, in this region here. Because when you use these isolatedly, you get a teleconnection here towards South Pacific, nothing here. If you use it here, this, you get something here and even something here, but the wrong sign here. And then when you put both of them, the strongest ones, together, okay, you get this half part here of this teleconnection pattern, but not this final part. This final part is really triggered from here. Okay, now we saw that MGO is important to predict the rainfall in this region because it affects the rainfall in this region. So let's see how the models in this S2S project predict the MGO. So here we'll use the same indices I described before, these RMM1, RMM2, which are based on EOF analysis of OLR and zonal wind in the on the equatorial belt. I showed some figure before. So the values, the combinations of values of these two indices define the phase of the MGO. And we are analyzing this period here. Why? Because this is the only common period. Each of these models has different periods of simulation, of reforecasts. And the only common period is this year. So the intention is to compare them. Here, you have, Caio mentioned these indices, this bivariate root mean square error and the bivariate correlation. So usually people take 0.6 as a threshold of a good simulation for this index here. And so you can see that the CFS is here, in between this average. Most of the models are here. There are the worst, and there are the best. So this is the best, because it has a good simulation of the phase of the MGO till the 4th week. So it's able to give you a useful prediction of the phase of the MGO here till the 4th week. The other the models here in between, till the 3rd week. CFS is here, so till the 3rd week. And this other index gives you the same information. This is the threshold used. You can see that ECMWF is able to give you prediction with reasonable error, not too large, so below this threshold, till the 4th week, while CFS is around, let me see, here, till the 3rd week. And the two indices give you more or less the same information. Okay, so I already told you the reasons why we chose these two models. Here, let me show you what the models reproduce in terms of the impacts in phase 8. In phase 8, we already expect strong impacts here over Central East Brazil. Okay, and more to the northern part of Central East Brazil. And you can see that the model reanalysis, the era interim, this year we will consider as observations, the model reanalysis. Well, it shows you negative OLR anomalies here. So it shows anomalies here, and they even extend here to the south, more than we saw in these observed OLR anomalies. We showed it before from the Brandt, the Liebman, and I don't remember, Allure. No. Schmidt and Liebman, I think, data set. And the era interim reanalysis shows you that teleconnection pattern with this cyclonic circulation here, which is responsible for this enhanced convection. As you can see, the phase 8 shows you this teleconnection already well formed, whereas in these composites I showed you before, in phase 8, you didn't see this closed cyclonic center so strong there. And the model shows you what actually in the observations you only see in phase 1, one phase after. And well, this is the model reanalysis. what the model considered observation. And you can see that you also have negative OLR here, so this is consistent with this teleconnection. The model shows it in phase 8. Keep this in mind. And here you have the model prediction for the 3rd week. So I skip it. First week is too much influenced by the initial condition. Second week is too small lead time, so let's take 3rd week. Well, look at this. The model at the 3rd week shows OLR negative anomalies here, enhanced convection, even stronger than in the reanalysis. And you can see that the teleconnection is even stronger in best format than here in the reanalysis. So this is really something that shows that even with a very complete and complicated model, this convection here is important for this teleconnection. When you had it relatively weak here, it wasn't so well formed, although better than you will see in phase 1. But here it's really well formed because you have even a stronger convection anomaly here in 3rd week than in the initial condition. So you have here in 3rd week the right signal in subtropical Central Pacific here. You have a strong teleconnection here, and you have a strong response here over the SACS, over the South Atlantic Convergence Zone. This, the model shows you for phase 8. In the observations there, we saw it in phase 1. Now let's see what the model shows for phase 1. In phase 1, look, here the anomalies, OLR anomalies, are positive and negative over this important region. And look what happens with the teleconnection here. You don't see clearly these cyclonic anomalies. There is still a cyclonic anomaly, but not that center we saw here. So there still is the cyclonic anomaly. There still is a reason for enhancing convection here, but the teleconnection pattern is not as well represented as in phase 8. And in the 3rd week for phase 1, oh, well, then it's terrible, because instead of a cyclonic circulation, we have an anticyclonic circulation. We don't have here a net OLR negative anomaly. We have here a mixture. So we have a weak signal in subtropical Central Pacific. We have weak teleconnection and wrong teleconnection. And we have weak response in the SACS. Well, I did the same analysis for the CFS. The CFS also shows in the model reanalysis better reproduction in phase 8, shows the same problems in the 3rd week. And here in phase 8, also more or less the same teleconnection here, but in the 3rd week, here in the SACS, you don't have signal, you only have it there in the equatorial region, and here you even have anticyclonic circulation. So the conclusion is the model produces in phase 8 what it should produce in phase 1. So it shifts the phase of the response. So this is an information that you could use, actually, in prediction to correct the model output. So now let's see what the model how the model reproduces these indices. This here you have already seen, so here. Here you have on the left this set of panels for ECMWF. On the left column, you have here these OLR composites for active phases. So these active monsoon days, here is that diapole, using the ECMWF reanalysis. Here you have the composite, let me see. Here you have the composite, yes, for active monsoon days, break monsoon days, observed the initial condition. Here for week 2, here for week 3. So what you see is that till week 3, and perhaps even, I think in phase 4 it's not bad either. You can see that the strongest anomaly here of OLR, it actually shifts eastward, out a little bit out of this region chosen for the index. And here you have the correlation of this index with the zonal wind. So does the model reproduce the relationship between this monsoon precipitation index and the zonal wind? Yes, it does. So you have here westerlies associated with more rainfall. And here for the CFS model. So the models reproduce reasonably these patterns of convection associated with the monsoon precipitation index. So the model recognizes this monsoon precipitation index, and it is also able to reproduce the relationship, the dynamical relationship with zonal wind at lower levels. So that's okay. And now let's see how the model reproduced the observed association of active and break monsoon days with MGO phases. This is the observed relationship. So here we took observed active and break monsoon days, based on rain gauge data. And we calculated for each phase of the MGO, you can see here the 8 phases of MGO. What is the proportion of days in each of these phases with MGO that is active monsoon? And you can see that the proportion is really highest in phase 1, which is expected. And second highest proportion in phase 8, which is expected. And the lowest proportion is in phases 3, 4, 5, and 6, which are that dry phases in that region. So this is the proportion of active monsoon days in each phase of the MGO. So there is a significant influence of the MGO phase on the occurrence of active monsoon days, and also on the break monsoon days. You can see that the highest proportion of break monsoon days occur at phase 5, and then 4, 3, and 6. And the lowest proportion in phases 1, 2, and 8. So let's see what the model shows. Does the model reproduce this influence of MGO on the active and break monsoon days? Yes, let me tell you that this here was calculated, this proportion, for a longer period. So it's a smooth variation here. But for this period, we chose for comparing the S2S models, which is this much shorter period. You don't have a very smooth variation here. But anyway, you have this maximum proportion of active monsoon days in phase 1, phase 8. And here you can already see that the model favors phase 8 as the phase with more active monsoon days. Do you see here? Much more than phase 1. Whereas in the observations, phase 1 has a greater proportion. And this is related with the problem in the teleconnections I showed before. And and in the week 2, 3, 4, this relative distribution here of active phases in the MGO phases, in the MGO phase, it starts getting different. Here, the phase 8 is also favored. In all of them, phase 8 is favored. Okay, I will do it in 5 minutes. Okay, and then here you have for break monsoon days, where you have also some, well, here is phase 4 as the highest proportion. Here is more or less the same for 3 or 4. But the main difference you see between phases 8 and 1. And why is it? Well, actually, the model probably does, completes that teleconnection from Central South Pacific to South America in less time than nature. So it appears at what in observation should be phase 8. Okay, this is for CFS2, and now here. These are the practical results. Here you can see the correlation skill for prediction of the weekly mean monsoon indices. For ECMWF, week 1, let's first focus on the green bars, which are based, which are based actually on all forecasts for all the days, whereas the red and blue are forecasts initialized only on monsoon active days or only on monsoon break days. Well, as the time is short, I will not analyze this here. Let's look at the green bars. So at first week, very, very high correlation. Here, 85 more or less, 0.85, very high correlation. For CFS version 2, 0.78 more or less, a little bit less. And then second week, this is for the precipitation index, is where we consider 0.5 as a threshold. So it's above the threshold, and here too. So first, second week, perfectly good prediction. In phase 3, so ECMWF prediction is here near the threshold. In phase 4, much lower. While CFS2 is already much lower here in week 3. So the performance of ECMWF model is really better. And when you look at the wind index, the skill is better. And although it doesn't extend to week 4, but it's higher here in week 3. So till week 3, we have a pretty reliable prediction of this wind index and a little less for the precipitation index. Whereas for CFS version 2, it drops a more evident way from week 2 to week 3. So I think till week 3, we could use this as a prediction of the monsoon break and active days. And perhaps with more reliability, the wind index to indicate the enhanced or diminished, decreased precipitation. This is just to show you why on week 4 we don't have skill anymore, because this is the correlation between the observed rainfall index in this region here and the predicted rainfall. So till the second week, you still have the predicted rainfall related with this region, but then it drifts outward of this index region. So it doesn't have anything to do anymore with this index, the predicted rainfall. Okay, so that's it. Here, there are the conclusions.
Questions? You?
Very nice discussion, at least very important. I just want to make a point here that perhaps one way of evaluating this should be considering more large-scale index. And why I say that? Because when you have this large-scale index, like the monsoon index, like the Lisan.
Like what?
Lisan, the one that I've been talking about. The thing is that it doesn't matter the biases in the models or where you put your boxes, because you would make it more what is the monsoon in the models, where is the monsoon, and then you can also capture the intraseasonal and interannual variability the same ways, and it's less arbitrary, because especially in the first figures, when you're comparing both indices, I realized, well, maybe the boxes are not in the right position. Maybe that is not a very fair comparison. Maybe things are better than what you showed in some cases, especially for the active and break phase. I've been doing this many times for India, for South America.
Well, in this case, I think the boxes are in the right position, because in terms of the precipitation, this index, it's very connected with the first variability mode, the first intraseasonal variability mode. So it reproduces completely the pattern for active and break days. And well, with respect of the dynamical aspects, for instance, the relationship with wind, the relationship is well reproduced by the models. You can see that all that panels, I show it there, show it this correlation between this precipitation index and the zonal wind patterns. And they show it even till third or fourth week. So that's not the real problem. I think the index reproduces well this variability. And well, if one uses an index that contains more parameters in it, I think perhaps we make it rather complicated, because people want to have the prediction in a very objective way. Oh, this region. So we chose this as a representative of the monsoon. Well, as a way of connecting it to the variability of the monsoon, but it could be any area. We did it for the South Atlantic convergence zone also. So it could be any area. But we chose an area that is very connected with the monsoon rainfall and the monsoon variability. so to show it here in this workshop on monsoon. But as I said, the user is interested, not although from the point of view of research, perhaps it could be very interesting. They are interested in rainfall in a certain region. What's the skill of the model in reproducing in this region? And that's why we chose a very simple index, which, by the way, is also connected with the monsoon variability, to show that there is some skill that is useful because it extends till the third week, the prediction, a useful prediction in this region. But okay, it could be, one could use an index that merges more variables as wind and precipitation and one factor score. But perhaps for the user it's not so easily understandable. But if you say it's rainfall in this region, that's it. Everybody understands it. It's more a question, yes, it's more an issue to make it very clear for the user. What does this prediction represent?
You can do similar. We can talk about this later.
Okay.
When we do the analysis for the one period, long period, or this period here.
79 to
the variability.
2009.
Yeah, the models can reproduce well the variability in such periods. We can see that the models can represent the teleconnections, the main modes of variability in this time scale, and in this subseasonal to seasonal variability. But have you looked at each year, for example, the beginning of the monsoon, or
the date of the beginning? No, that's this is on the radar. Yeah, no, this is useful information. You could do it, I think, but we didn't do it yet. But I think yes, it would be a next step. So with these predictions of rainfall, using an index of rainfall for there are criteria for the beginning of the monsoon season, the demise. You could use this predicted rainfall to predict the beginning of the monsoon. You have it for 30, 40, 60 days. It depends on the model. So you could predict with perhaps 4 or 3 weeks in advance the beginning of the monsoon season. Yeah, you are quite right.
Yeah, because this is what the users
need. This would be a very useful information, of course. This could be obtained from this predicted rainfall. Yeah. Yeah, this could be a very useful information. Yeah.
You showed that the phase 1 of MJO is the one that you have more active days of the monsoon.
In this region. Yes, okay. Using this region as a representative. Okay.
There is a recent research that shows that in the phase 1 and 2, you have more blocking events in the southeastern South America. Blocking, I mean the South Atlantic subtropical high, more frequent.
And South Atlantic subtropical high, more frequent in phase 1.
Yes, also.
Might be, I don't know. I didn't look at the...
My question is about that, if you did look at...
No, I didn't look at this particular aspect. But yeah, it would be interesting to see. How, this fits into a discussion we had, Iracema also participated, and somebody else, I think it was even you, so to look not only at precipitation, but to look at the other features, the characteristic features of the monsoon. The Bolivia high, the intensity of the sacs, the Atlantic subtropical high, and so on and so forth. So some characteristic features. So instead of having just one average map of the characteristics of the monsoon, Chacolo in this kind, you could have a map for each situation, each phase of the MGO, each phase of the MAO, the IPO, and so on and so forth. Yeah, it would fit in this discussion. Yeah, to look at the features of the monsoon in a more comprehensive way, not just
maybe I don't know if
precipitation.
this feature can be related to that issue you observed there. I don't know if it can be related to this, where you say there they tend to produce the MJO in phase 8, but the observations show in phase 1.
In phase 1, yeah, the model, yes, I attribute this to a quicker teleconnection in the model than in the nature, okay? So the model sees this forcing anomalous convection in Central South Pacific and establish this teleconnection in a quicker way, in less days than the nature. So it shifts the impacts over South America. They happen in phase 8 instead of phase 1.
Did you have another question there?
Thank you for the presentation.
Okay.
Oh, sorry. Thank you for the presentation. I had a question. It also kind of links to what you had talked about throughout the workshop, and it's you've talked about MJO, but you've also talked about ENSO, right? And so there's this combined effect, and this seems like it would be ripe for including both aspects in terms of predictability. So I was wondering if you've looked at that.
Yeah, very good point. Caio talked a little bit about this. When calculating this is a very good point. When calculating these indices, RMM1, RMM2, which define the phases of MGO, one tries to take out the effect of ENSO. But the way it is done, I don't believe very much we take all the effect out. Usually people take out the average of the last 120 days. ENSO doesn't have a cycle of just 120 days, which is 4 months. So this is how it is explained by Gottschalk. Actually, Gottschalk says, no, we don't do this because ENSO is already taken out by another thing. But I also don't believe it's all taken out, the effect, by this other method. So I think something of ENSO is still there. And you are quite right that ENSO has a very significant influence on the MGO effects. There is a student of our group who is looking into this, and there is really a significant difference of the impacts in phase 1, 2, 3, 8 with ENSO and without ENSO. Looking at here, totally neutral, very well characterized, and years very well characterized at ENSO or El Niño or La Niña, there is a significant effect because ENSO has a big impact on the SST in the convection in this Central Pacific region. So obviously, it impacts on the anomalous convection, which is important for the connection with South America. This is expected, really. One has to separate these things. We are looking at this from another, with another approach.
But also not necessarily separate it, because for a user who's interested in precip, it might be good to have both pieces of information together. So.
Yes, you can, no, we are doing it this way. Years with El Nino, okay, you know if there is an El Nino going on. Then you look for a pattern that you have already studied. You know that this pattern is most probable in this year. If it's a neutral year, you also know it. And then you would expect another kind of impact. If it's a La Nina, another kind of impact. But yes, ENSO has influence, yes, because it affects this region which is very important for the teleconnections towards South America. And not only towards South America, also North America. Yeah?
Well, thank you very much, Alice. And there is a change in the program, if I understood properly. We are going lunch now and back at 2. And the discussions on the needs of modeling studies and interactions with students goes after.
Interaction with students tomorrow.
Tomorrow.
And the modeling discussion
At the end.
At the end.
After the short talk.
So let's go lunch and be back at 2.
Parabéns, Alice, bacana. Precisamos colocar uns negócios desse usuário também. Não, podemos modelos. E olhar para os mecanismos.